Welcome everybody. We are expected to find the value of x given that 7th root of 5 raised to the power of 16 positive 5 raised to the power of x divided by 5 raised to the power of x positive 5 squared is equal to 5. So what I wish to do foremost is taking 7th power both sides. So this is actually 5 raised to the power of 16 positive 5 raised to the power of x divided by 5 raised to the power of x positive 5 squared. This is actually 7th root, right? So it means this is raised to the power of 1 over 7. What I wish to take is I would like to take 7th power. So raising this term to the power of 7 and raising this term the right hand side to the power of 7. So clearly 7 gets cancelled, giving me 5 raised to the power of 16 positive 5 raised to the power of x divided by 5 raised to the power of x positive 5 squared is equal to 5 raised to the power of 7. So let me cross multiply. So this is going to be giving me 5 raised to the power of 16 positive 5 raised to the power of x is equal to 5 raised to the power of 7 times 5 raised to the power of x positive 5 squared. Let me distribute this. This is 5 raised to the power of 7 times 5 raised to the power of x positive 5 raised to the power of 7 times 5 squared. On the left it's 5 raised to the power of 16 positive 5 raised to the power of x. So now what I wish to do is I would like to bring this term to the left and move this term to the right. So this is 5 raised to the power of 7 times 5 raised to the power of 2, right? Now a raised to the power of m times a raised to the power of n is equal to a raised to the power of m positive n. So from the law of indices I can use this formula. So let me move this quantity to the left. So it's 5 raised to the power of x positive 5 raised to the power of 7 times 5 raised to the power of x is equal to, this is going to be 5 raised to the power of 9 positive, as I mentioned to you, I'm moving this 5 raised to the power of 16 to the other side. So it's going to be negative 5 raised to the power of 16. Right, so this is going to be equal to 5 raised to the power of 9 plus into minus is minus 5 raised to the power of 16. I'm going to write it as 5 raised to the power of 9 positive 7, and a raised to the power of m positive n, which we have here, can be rewritten as a raised to the power of m times a raised to the power of n. So that's exactly what I'm going to do. So this is going to be 5 raised to the power of 9 negative 5 raised to the power of 9 times 5 raised to the power of 7. So this is on the left hand side. Now on the this is for the right hand side. On the left hand side we got 5 raised to the power of x and 5 raised to the power of x. So let me just take 5 raised to the power of x out. So there is one small corrections I wish to do here. Now 5 raised to the power of 7 times 5 raised to the power of x, when it moves, this is going to be negative, right? So that has to be placed here. It isn't positive. Of course we can place the positive sign, but when this quantity moves to the other side, the signs will change. So I'm placing a negative sign here. Now 5 raised to the power of x is taken out, so this is going to be 1 negative 5 raised to the power of 7, right? 5 raised to the power of x times 1 would give me 5 raised to the power of x, and 5 raised to the power of x times 5 raised to the power of 7 with a negative sign would give me this quantity. Now let me write that down. 5 raised to the power of x followed by 1 negative 5 raised to the power of 7. On the right hand side I can take 5 raised to the power of 9 out, so that is going to give me 1 negative 5 raised to the power of 7. On the left hand side I got 5 raised to the power of x of 1 negative 5 raised to the power of 7. Now clearly you can see that 1 negative 5 raised to the power of 7 and 1 negative 5 raised to the power of 7 can be cancelled, and that in turn would give me 5 raised to the power of x is equal to 5 raised to the power of 9. Now the bases are same, so the exponents can be equated. So this will mean x is equal to 9 is the final solution, and that is a good place for us to stop. Thank you students, enjoy your night.